Good morning. Now I'll discuss this matter chapter according to ICSE syllabus class 8. Okay. So in my last video of this matter chapter, I discussed about the solid, liquid and gases. Okay. And their explanation of the kinetic model. Okay. Now I'm starting today with the interconversion of the states of matter. So, what is this interconversion of the states of matter? It is the phenomena of change of one state of matter into another and then back to the original state without any change in its chemical composition. That is, its chemical composition does not changes, but from one state of matter it changes to another. Okay, that is from solid to liquid, or liquid to gas, and again to its original state, that is from gas to liquid and then from liquid to solid. So this changes of state of matter happening without any change in its chemical composition. Okay, that is known as interconversion of states of matter. Okay, now this change is caused by two things. One is change in temperature and one is change in pressure. Okay, these two things are involved for this change. Okay, for this interconversion. Now first we come to change in temperature. For this, see, interconversion of solids into liquid or liquid to solid. So this condition, this thing, if for happening for conversion of these solid to liquid and liquid to solid, the solid can be converted into liquid by heating. We need to heat it, that is temperature we need to rise, so that the solid melts to liquid, and liquid can convert into solid. Then again there is a temperature change, that is cooling. Okay, so if the solid, if the liquid is cooled, that is temperature is lowered, then the liquid changes into solid. So there is a change in temperature in both the cases. For example, ice at 0 degree centigrade will change into water when heat is supplied. Okay, and vice versa, that is water changes into ice when water is freezed. Okay, so there is a change in temperature during the interconversion of solid to liquid and liquid to solid. Next is interconversion of a solid into liquid and vice versa. Okay, here there are some certain processes are mentioned where the when there is a interconversion, that is when solid changes to liquid or liquid to solid. Some processes are melting or fusion. It is a process due to which a solid changes to liquid state by absorbing heat energy. Okay, so when we tell that solid has changed to liquid state, that means solid is melted or fused to liquid. So for this this term, that is melting or fusion, that is, it is the process of changing solid to liquid state by absorbing heat. Again, freezing or solidification is the opposite of melting or fusion. Freezing or solidification is the process in which the liquid changes into solid state by giving out heat energy. It gives out heat energy, that is, it cools down, temperature cools down, temperature lowers down to change the liquid into solid. Then a constant temperature is required when this change takes place at a constant temperature, and that is known as melting point or freezing point. Okay, now melting point is the constant temperature at which the solid changes into liquid. It is that constant temperature. Melting point is that constant temperature when the solid changes into liquid by absorbing heat. Again, freezing point is that constant temperature when liquid changes into solid by giving out heat energy. Okay, now there's a note that the numerical value of melting point and freezing point is the same. For example, the melting point of ice is equal to the freezing point of water, and that is equal to 0 degree centigrade. Now, the melting point of pure subject is always a constant quantity. When the substance is pure, the melting point is also constant. okay, and is a good measure to find the purity of the solid. If we see that the solid melts at a particular temperature, constant temperature, okay, that is the melting point is fixed. That means, for example, see, if we see that the ice is melting at 0 degrees centigrade, that means we know that the ice melting point is 0 degrees centigrade, and we see that the ice which we have taken, we see that it is melting at 0 degrees centigrade at a pressure known as at a pressure which is known as 76 centimeter of mercury. Then that ice is a pure ice. We will deduce that the ice which we have taken to melt it, that is a pure ice. That is, it is not containing any impurity. If there is any impurity present in the ice, then their melting point of the ice would have reduced. Okay, the melting point, for example, see, impurities which are present will reduce the melting point of the pure solid. For example, see, melting point of paraffin wax, it ranges from 62 degrees centigrade to 65 degrees centigrade because it has certain compounds in it. That is, this paraffin wax is not pure. It has certain compounds in it which according to their proportion, this compounds which are present in the paraffin wax, the compounds are present in certain percentages. So if their percentages differ, that will change their melting point. Okay. Next is interconversion of liquids into gaseous state and vice versa. See, liquids can be converted into gases by heating. Again, here also liquids gets converted when we heat certain liquid, it changes into gas, or when we cool down certain gases, then it will change into liquid. Again, there is a change in temperature. For example, the water at normal pressure will change into steam at 100 degrees centigrade when it absorbs heat. Again, steam at 100 degrees centigrade will change into water when it is cooled, that is by giving out heat. Okay. Now, there are certain terms which are related to this interconversion, that is boiling or vaporization. So, it is a process due to which the liquid changes into its gaseous state on heating. Again, condensation or liquefaction, that is a process in which a gas changes into liquid. Okay, that's the opposite of boiling, where the gas changes into liquid by giving out of heat. That is, it cools down, the temperature cools down. Then evaporation is also a process in which liquid slowly changes into gaseous state at a temperature which is far below the boiling point of that liquid. Now, the boiling point is the constant temperature at which the liquid rapidly changes into the gaseous state by absorbing heat, and condensation point is the constant temperature at which the gas changes into a liquid state by giving out of heat. Okay. There's a note, the numerical value of condensation point is equal to the boiling point, and that is equal to the same. That is, for example, see, this water changes into steam, that is its boiling point. Water's boiling point is equal to the steam, that is steam's condensation point, that is steam changes into water, and that is equal to 100 degree centigrade. At this constant temperature, either water changes into steam or steam changes into water. Okay. Now, next we come to interconversions of liquid into gaseous state and vice versa. Okay. Now, here the boiling point of any pure liquid at a pressure of 76 centimeter of mercury is sharp. That is, the boiling point as like the melting point, here also the liquid when changes into gas, that's boiling point, that is also for pure liquid it is constant, that is it is sharp. It is used for the finding the purity of the liquid. From the boiling point we can deduce that whether the pure liquid is pure or not. The pure impurities if present in the liquid, that will increase the boiling point of the liquid. For example, when a few spoonfuls of salt are dissolved in water, the boiling point becomes more than 100 degree centigrade. Okay. Now another conversion, that is direct interconversion of solid into gaseous state. That is directly solid changes into gas and gas to solid without becoming liquid. Okay. Now some solids on heating directly changes into vapors without first changing into gaseous state. Like that, again vapor cools down into the solid without becoming liquid. So that process is known as sublimation. So sublimation is a process due to which a solid directly changes into gaseous state on heating without changing first into liquid state, and the gaseous state on first changing into and the gas state again on cooling it directly changes into solid state without becoming liquid. So the gaseous form is known of the solid is known as sublime, and the solid state of the gaseous state from the gaseous state on cooling, that is known as sublimate. The solid state is sublimate, gaseous state is sublime. Okay. For example, ammonium chloride, iodine, solid carbon dioxide, naphthalene, camphor, these all convert to their gaseous state by sublimation. Okay. Next is change in pressure. Okay, this interconversion of states of matter, that also is dependent on the change in pressure. Okay, first we discussed that the change in temperature can affect, how does it affect the change in the interconversion of states. Okay, it affects the interconversion of states of matter. Here we'll start the discussion of how the change in pressure affects the interconversion of states of matter. Okay. The states of matter is altered with the help of atmospheric pressure. When pressure is lowered, boiling point of the liquid is lowered. When pressure becomes down, the boiling point also of the liquid goes down. Due to this, the liquid changes rapidly into gaseous state. For example, water boils at 100 degrees centigrade and rapidly changes into steam. If the atmospheric pressure is lowered, that is when we go up in the hills, okay, there the atmospheric pressure is lower, so water will not boil at 100 degrees centigrade, it will boil at a lower temperature than 100 degree centigrade. Okay, so it boils at a temperature far below 100 degrees centigrade and changes into vapor state. Carbon dioxide is a gas, normal conditions of temperature and under normal condition of temperature and pressure. It can be liquefied by compressing it to a pressure 70 times more than the atmospheric pressure. So if the pressure is increased, carbon dioxide gas will change into liquid carbon dioxide. Okay, so if the pressure of the liquid carbon dioxide is suddenly released, that is where the pressure is increased, if the pressure is released, okay, so some amount of it, that is of the liquid carbon dioxide, will change into solid carbon dioxide. Okay, so this is the interconversion of the states of matter. Okay, so this is the diagrammatic representation of the interconversion of the states of matter. So I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box, share with your friends, and please do like the videos. Okay, if you are liking it, and also do subscribe to get the notification of my next video. And according to your demands, I'll start with this language of chemistry after this completion of this chapter, and the question answers I will discuss along with that language of chemistry only. Okay, so thank you for watching, and thank you.